everybody. In this video, I want to talk about the complement of an event. So, consider the probability of choosing an ace from a standard deck of playing cards. So the event is choosing an ace. The probability of this event is 4 out of 52 because there are 4 aces in a deck of 52 cards. So what we want to talk about today is the complement of that event. So if E1 denotes choosing an ace, then the complement of E1 is denoted by this notation, E1 prime, if you will, and it is the probability of not drawing an ace. So if the probability of drawing an ace is 4 out of 52, or simplified 1 out of 13, the probability of not drawing an ace are all the other cards. So there are 48 cards in the deck that are not aces. So 48 out of 52 is 12 out of 13, simplified. So notice that the probability of E1 complement is the same as 1 minus the probability of E. I summarized that on the next slide. This is a formula you want to have memorized. The probability of E complement is 1 minus the probability of E. Okay, now let's look at a more a practical example of this. You'll see a lot of these in your homework and on the quiz. So it says that in this quality control problem, a shipment of 60 game players, including 9 that are defective, is sent to a retail store. The receiving department selects 10 at random for testing and rejects the whole shipment if 1 or more in the sample are found to be defective. What is the probability that the shipment will be rejected? Here's the key pieces of information from this. There's a sample space of 60 game players, so there are 60 games altogether. Since 9 are defective, 51 have to be perfect or in good condition. And remember that the store is looking at a group of 10 and they are randomly choosing 10 of the Game Boys to inspect. So the other piece of information is it says the entire shipment will be rejected if 1 or more from the group of 10 is defective. So that means that we're going to have to find the probability that 1 is defective from that group, and then add to that the probability that 2 are defective, and then add to that the probability of 3, and then 4, and then 5, 6, 7, 8, all the way up to 9. So this is going to be a really long, complicated process and very tedious. There's got to be an easier way to do this, and there is. It's easier to use this idea of complement and find the probability that none are defective. So to find the probability that none are defective, that means we're going to do, so that's what we're doing. We're going to find the probability that none are defective. That's the complement of the probability that at least 1 is defective. So the probability that none are defective is the combination of 51 items taken 10 at a time over the combination of 60 taken 10 at a time. Now the reason why we're using 51 is, remember, there are 51 good ones. So if we want none defective, our group of 10 has to come from those 51 that are good. The entire sample space, what could have happened is I am taking 10 from the 60 that there are. So the combination of 51 taken 10 at a time over the combination of 60 taken 10 at a time is 0.1695. This is the probability, it's approximately the probability of none being defective. So 1 minus that is 0.8305, and that's the probability that at least 1 is defective. I hope this helps clear up any questions you might have from these problems that you'll see in your homework. Good luck. Email me if you have any questions.